audible? Great.
Can we have the Pranshu's mic on, please? Yeah.
Hello. Hey,
Yes.
yeah, this is good. All right, then let's get started.
Hello, everyone, and very good afternoon. Welcome to the post-lunch series session for MLDS 2025. And this is Chavi Chawla. I'm a lead data scientist at Mathco. And with me, my co-presenter today is Pranshu. I
Hi,
guess
everyone.
you all would be knowing him by now. He's popular.
No.
So yesterday he hosted a session. So together we are going, now for this particular session, we are going to basically present our technical paper, which is basically on enhancing photorealism and customization in digital advertising. Um, so all of you are basically by now would be aware of text-to-text modality. Basically, everyone is aware of what ChatGPT is and how you basically feed a prompt, which is like an instruction. It's like a text which you give to the large language model and expect an answer back from it in the form of text. We are going to talk about text-to-image modality, wherein we are going to feed in text and as prompt and expect an answer in the form of an image, right? This is also not a very unfamiliar area, but let's see what it basically holds. But we are going to talk specifically in the advertisement agency, advertisement domain, which holds a lot of potential where image modality can be applied. So moving forward, right. So the areas where today the advertisement agency industry where text to image modality is most commonly used is in ideation and iteration, right? There is a need for basically generation of new ideas and to rapid prototype basically the ideas and iterate over those things, right? The second is character design, creating a new concept altogether or a functionality in the industry. Social media marketing is a very, very known area. Uh, and the fourth dimension is cost efficiency. We want like fast simulated environments, like for example, VTD car maker in automotive industry. Likewise, we need, in advertisement agency also, we need fast solutions, fast prototyping. We don't have to photo shoot and go to locations. We can have simulated environments and simulated backgrounds for placing our products and creating advertisements. Then real-time adaptability. Quickly, we have an idea, we can actually prototype and use it there and then. Visual storytelling is also, when GPT first came, it was very famous, so everybody's aware. And of course, customization and personalization is the heart of this modality because you can have, this is where basically the lot of integrity comes from the product and from the customer's end. Because these solutions, no matter how much flexibility it gives you, at the end of the day, what matters is it consumable for your organization? Is it personalized to you? Is where the central theme comes in, right? So moving forward, what is basically product realism? Here you basically see two images, right? And one on the left is a famous a brand for a drink. And what we have given here is like, can you give me a background with, let's say, beach background with this product? And what we get here is this image, right? On the right, you can see the same product. And what I've asked in the form of instruction to the known LLMs is, can you give me the same picture with a sunny theme there? Which image do you think makes more sense from the product integrity point of view?
The right one.
Of course, the right one, right? That's an obvious choice. The reasons being the product is intact. The boundaries are intact. There are no projections out there, right? This is what we call as photorealism. What does it mean is adherence to the prompt in addition to the integrity of the product being maintained along the lines, right? So this is the central theme of our talk today also. We are talking about enhancing photorealism, how our solution, the model or the approach that we have used is going to benefit, and why there is a, like, what is the trade-off between the earlier rule-based approaches versus ours, what is different, what we are proposing here. The next, I think, from there, Pranshu will take you forward into the deep dive solution approach. It's a iterative in nature, how we started with off-the-shelf models and how we came to the present-day solution. And last but not the least, the cherry on the cake, the entire framework, what we are proposing, it's like a ready-made home solution which you can take away and use it for your own applications, which is like the advertisement or the banner creation itself, right? Going forward, I'll just basically explain this, and then Pranshu will take you to the journey. So basically, we talked. Now you all are familiar with what photorealism is, and what you see here is the standard off-the-shelf models. You would ask, why would you not use those? For example, DALI or SDXL, that is standard, basically stable diffusion models off the shelf. Why we would not prefer to use them is for the following reasons. You see the images which are right-ticked are the ones where we given the prompt and we've got the right results. Because probably the model was trained on the data, maybe the brand which you see is more the images on which the LLM model would have been trained into. And that's why it's giving and maintaining the product realism. By that I mean the integrity of the product that we talked about, right, without distorting the image. But on the ones on the right, which you see as crosses, it is there where the brand integrity was compromised somehow. That means the product, the background was okay, maybe, or the background was not creative enough or generative enough, and somewhere the product integrity was also compromised, right? So what we are trying to achieve here, we are trying to basically find a fine balance between the two, between the control and the generative power of the LLMs, right? So here you see, for example, the figure on the left hand side. We are going to basically what we are striving towards is the start point to the ideal state, which is to say, like, we are trying to find a balance between the realism and the generative approach, the control versus the chaotic nature of the LLMs that we see today. And right, so this is where the theme pops up, and we'll walk you through the journey. I think, Pranshu, over to you.
All right. Thanks, Avi, for the introduction. So, the moment when we were experimenting with this and we identified that problem statement where a lot of our customers who were into the advertising industry, who are struggling with keeping their products intact in their digital advertisement, that's where the need of this framework started. And when we started with this experimentation almost a year back, the first common solutions out there which was available with us was the in-painting models. Let me quickly tell you what in-painting as a technique is. So it's a way that how would you basically create some sort of an instruction for your model to be able to tell the model exactly that what part of the images I want you to not touch, and what parts of the model what part of the images I want you to be generative about. So if you see here on the black side, which the black images that you're seeing are the kind of masks generated for a particular product. So in this particular case, the mask generation process usually like there are so many approaches that have come now in the market with the advancements of Gen AI. So suppose if you can actually prompt your original image by saying that I want to just mask and preserve, let's say, the dog and the bench in it, and it will basically use that prompt to create that mask. Or if you don't know exactly what product is maintained, or if there's no recognition for that product, you can use a coordinate based system to tell what exactly how you need to generate the mask. Or there are like a lot of new algorithms where you can basically use a foreground and a background segregation to be able to identify automatically what your product is. Now, apart from the input of the actual image, the second input which goes is the mask image, which is right now telling the model that, hey, this is the part which I want you to understand that I want to preserve, and other part, the black side of it, is where I want you to be generative about. And then you give the additional input, which is the prompt here, that sit on the swing, for example. So the other remaining part of the black image got generated with this instruction. Now, this was the starting point where how we started this journey of building our framework. Now, as you would assume at this stage that now, since you have an approach which uses mask, you would be able to preserve your information which is contained in that mask. And you would assume at this stage that, now my Pepsi is not getting deformed, my dog is not getting deformed at this stage. But however, when we went ahead, when we experimented a lot more, what we realized was, because there was no additional information provided about the black part of the image, there were natural extensions that started coming, because the model was free to do as much as generation in the other area. So if you see in this particular case, the white side of it, now the model was trying to be over creative about it, and then it started converting this into a bit of a bottle, which is now not acceptable because the product intactness or the product realism aspect of it is lost now, because what I was trying to retain was a can, but ultimately it came out as a bottle. Similarly, in a lot of different cases, what we saw was it would add its own creativity, like it would create natural extensions to a lamp as if it had a lot of wires in it, or so on. Now, this started creating a problem for some of our enterprise customers, because they have those products which were very, very unique to them. They had a very, very specific characteristic of a particular product, and they did not want that characteristics to go anyway. And that's why they had this resistance toward using some of these generative model. That's when we researched a bit more, and we got familiarized with another approach called as control net. So usually these diffusion models that you work with, be it your stable diffusion model or any other diffusion models out there in the market, you can actually have a control net taking a bit more, giving you a bit more control over the generation part of it. So what that control net usually does is it basically gives you an additional control image, which can be in the form of various inputs. So for example, could be a depth image that you would want to give to make the model understand how the depths look like. In this what we have used is a canny image generator, which is basically generating the boundaries of that particular image. So to give a control element to it, there are multiple options and there are many more ways which are available. In this case, what we have done is we have used the canny image, which generates the entire the edges of the particular product, and then this control image goes as an additional input to these diffusion models, saying that, hey, this is the direction which I want you to follow, take this as an instruction, and then don't let these control lines or these control images get changed. So this is how model now starts thinking in the direction while it is doing generation. But again, as we experimented with a bit of this with more, and as we started generating more and more designs with it, there's another challenge that came onto in front of us. So there were a lot of business users who were uploading their actual product catalog images, and because the product catalog images had some extra backgrounds in it, for example, in their product catalog image, there would be this lamp already present on a table with a background of a sofa. What happened in the control image was those elements got preserved. And now those elements which got preserved in the control image also influence the output generation. So if you see, the difference between this input and the output is the table parameters did not change that much, and the sofa also remained as it is. So what problem we saw here was the control net also needs to be tamed a little bit in such a way that the extra noises which came from the background has to be eliminated somehow. That's when the sorry. Yeah, that's when the overall solution approach came up in our mind, where we thought that we would utilize the power of in-painting technology with the control net, but we would add our own additional layer of it, which we'll create a modified canny image. So now let me tell you the process of what modified canny image generation is all about. So the mask which we generated as the first step, the control image that we generated as the second step, we combined the two and we filtered some of the extra noises around the background. So that led to only the control image which was with respect to that particular product. In the first case, we had used this in mask generation process to ask the user to be able to point out what is the product, and in this case the entire control was generated and then filtered to this. Now this control image what we have obtained here is very, very specifically telling the model that this is the boundaries of the product, this is the characteristics of the product which you do not have to modify, and the mask region is telling that this is the area that I have to preserve. So what I've done is, with this approach, I've come to a place where I've clearly now in a more detailed manner clearly laid out the instructions for the model, that what is that place where you need to be generative about and what is that place where you need to follow my instructions. So then the overall process starts with, the first step is you generate the mask, the second step is you add this extra layer of modified canny edge, and then these in painting there are so many open source in painting architectures available. We have used here the stable diffusion XL control net in painting pipeline, because that was one of the most outperforming control net pipeline that was available out there. And then the output got generated. Now, one of the major differences that you would see in one of these inputs and the outputs is the previously that sofa example which we had seen, it was getting influence in the background, but now the model has removed that in from this particular output, and this is a bit more, the model has got a bit more freedom in terms of getting the output. So I have another example here where in this case this was the input, and if you see here the table structures have also started changing and the backgrounds have also started changing, which basically gave us a way to be able to be more creative with our processes possible. So overall this is our technical approach that we had followed, and this is the technical approach that we have presented in our paper, and we'll move forward from there. And now we'll talk about the banner creation process. So once your the image is ready, now Chavi will talk about how do we translate this into a banner which is useful for our customers to generate their ads. Chavi, over to you.
Just one more piece of information I want to highlight was also what makes it unique for the advertisement industry per se. There is a layer of parameter tuning, which, of course, I don't want to go back to the slides, but there's a layer of parameter tuning that we have also developed on top of it, which makes it unique specifically for the advertisement industry. These are the suggested parameters. Of course, there is always room for innovation, always room for improvement. But these are just fine-tuned to basically cater to the use cases that we are going to probably show. Lastly, combining the model that we have so far reached from the iterations that we have just gone through, what we also realized that ultimately what sails through is a package. You cannot just give a model and expect the client to basically use that model. You need a shipping element. Now, what we mean by that is the entire solution. So you have to build a software framework around it to basically package the solution and deliver it in the form of what client needs, which is basically an automated advertisement creation framework. What it entails is the generation of an image, a photorealistic image, using the framework what we have developed, and alongside some guidelines, which is the rules or the rule-based approaches which the conventional approach, for example, Adobe or Canvas has been using in the past. So developing the software code to uh, basically preserve the rules which the client gives. For example, I would want my image only to be on the left side of the banner. I would want the text to be this side. This is non-negotiable. This is how I want my banner to be. It's a deterministic system. So those things I can see, right? So giving that as a giving that as a rule book plus the image which is being generated is combined to actually then give a complete banner solution, right? And lastly, I think moving over to the next slide are the examples, real examples of image and the banner generation. So on the left, you can see, for example, the lamp is there and the consequent banner which goes around it. You can see that the product integrity is preserved as is. Similarly, for example, the line for uh, uh, the player being there and the player being there on the soccer field. So you can see that nicely the edges and the product realism is preserved. Yeah, so that is it for today. And we welcome any questions that you might have. You can just write to us. Yeah, that's all. Thank
All
you.
right, thank you everyone.
Thank you, guys. So I think we have any questions. We can take questions.
I think there are some
Yeah.
questions. You can go.
Can you pass the mic, please? Yeah. Yeah. Please introduce yourself when you ask questions. Sure.
I think there's one more question there.
Uh, Please use the mic. Give it to him.
Right. I think so. Sir's question is that how are you preserving the resolution for the background and the foreground image which you supply? So it's more of a rule base, so that we can always, there are state-of-the-art platforms or the solutions there, or some software packages which we can use on top of the solution, where we can modulate these things. So once the image is generated, either we can compress, photo compress, or already give it a. I mean, what I mean is that doesn't have to be part of the model per se, LLM model or the modality. You can on the top introduce such changes and control. This is deterministic. What amount of resolution you want. Right. Oh, okay. Right.
So
Right, right. There are off the shelf, but
yeah,
that's
there's one more element to it. So usually like no, so if you are having issues with the output of the model where the resolution is a bit of a problem, recent enhancements have come across on super resolution as well. So what you can do is you can add another post-processing layer on top of the results which are generated from your base diffusion models. You can use super resolution techniques to actually take from the base resolution that you have got from the diffusion model to any HD standard format. So they have those DPI conversions which you are talking about, and that way you can upscale the quality of the model to a great extent. So that could be another model that you can use. No, no, no. You will have to do it from your end
you
itself.
have to
Just before
integrate.
giving the result to the user, you might have to like use a super resolution model to be able to upscale the quality and then give the final output to the user. I hope that answers your question.
Hey, hi.
Hi.
My name is Anubhav. I'm from EY. My first question actually you answered with the post processing step that you just
Okay.
suggested. My second question is around is this currently as a service from Mathco, or is it something that you know is, as a product you are selling it into the market, like you have a
As a
website,
Right.
customers come and they do it?
So
How does it work?
correct. So we have a nucleus platform, which I think you've heard of recently. We have met. So basically, this is one of the custom product that can be created on top of nucleus. So in when we work with a lot of enterprises, because the use cases are variety of in nature, we build these kind of custom products for our users. And this was an example of one such custom application that was specifically created for a customer who was in need of it. So that application, if there are enterprise needs where you are looking for a similar application, we can have another nucleus application completely customized and be given to you.
So as such, it doesn't exist, but it can.
as a right
As a
now as a
service, right now it
service
does not exist,
in-house
but
platform,
yeah,
but
Okay,
not
thank you.
as a
yeah,
Thank you, Pranshu and Chavi.
all right.
I think any questions,
Yeah,
we
I
can
think
take it.
there are.
Okay, one last question you can ask.
Yes, very quick question. So, one of the issues that I have faced personally when doing something like this is if the product image that you have, if it has any kind of strong lighting or shadows, then the mask region just kind of fixes that lighting because the background now is forced to kind of follow that lighting. So, is there any good way to fix that problem? Because if I denoise it too much, then the product itself gets messed up.
Yes. So I think this problem, like a lot of people have handled either in two ways. One is there are some pre-processing techniques where you have like specific. So these the lighting conditions which you're talking about are nothing but preset conditions written in order to come up with something like a specific direction of a light, or like a direction of maybe like a sun, how it needs to look at, or the shadows that needs to be created. Now some people, what they do is they pre-configure some of these settings and give you already in their software. So what you do is like you open up like some of these tools, they will have preset conditions like lighting from the left, lighting from the lighting from top, and lighting from bottom. Now because there are already controlled parameters which are governing this, either you can introduce those same parameters in your pre-processing layer as well, so that whenever an output gets generated, you use these optimizing parameters, so that always the model will use these parameters and put the light like that. And now there are newer models which are having, because in video generation specifically, a lot of people are using these lighting conditions and zoom in, zoom out. But ultimately, if you look at it at an architecture level, be it lighting conditions or be it camera movement angles, all of these are nothing but change in the parameters that you are having. So if you have any specific requirement, if you want to change the angle, a lot of people are actually doing it. I want a very close photo shot of my product. Now in that case, you can't, you are providing still an original image, but how do you come to a close photo shot is because you have changed the parameter to make the camera zoom in into the image a bit more. So that's the role of those parameters. So similarly in your case, either you can add these parameters before you have generated the image or after the generated, and these preset configurations can be used.
I think
Right.
one more thing which works out of the shelf, at least in my case, is morphing and perspective calibration. You can try those, which is like a pre-processing technique, as I said, but those work. You have to handcraft certain things if you are very deterministic about what you.
Uh, I have
Right.
one question.
Thank you, Chavi and yeah, Pranchu. So Yeah, thank you. Yeah, yeah.